sometimes or nevers. That's a good one. So this is based on the card sort thingy that we did, where we're looking for when it's always true, sometimes true, or never true. So a sometimes true would be if we'd have a solution like x equals 3. Always true means we get something that's always true, like 2 equals 2. And never true means we get something that's false, like 7 equals 24. So we can look at this and kind of do some simple math to try and figure out what our situation's going to be. So I'm going to bring it in on our A here. And what I'm going to do is I'm going to distribute on both sides over here, just so we can see what's happening. We have 8x plus 24, and that's going to equal 8x, because this is a negative 2, plus 24. What do we see there? What do we notice? They're the same. They're exactly the same. So is 8x24 gonna equal 8x24 always? Yeah. You could keep going, and we could subtract 8x from both sides. We'd get 24 equals 24. That is definitely gonna be always. They are the same. They are the exact same. So we didn't have to get all the way down to a solution. We got to the point where we could see it, and then we can stop and save ourselves some time and effort. This one is like one on the card sort that was like the big trip up one that we struggled with. Because x plus 4 quantity squared that means x plus 4 times x plus 4. So think of it that way. When we would multiply it out algebra 2 style. Because when we multiply that out algebra 2 style, what do we get? What's going to go in this box? X squared. And here? 4x. And here, 4x. And our last box, 16. So what we really have is x squared plus 4x plus 4x, which gives me 8x plus 16. And we want to know when that equals x squared plus 16. Ooh, that's crooked and tilted. Love that. Really doesn't look that tilted on my iPad. So looking at this now, it's still a little unsure. What can I do to get my x squareds together?
Subtract.
Yeah, I'm going to subtract an x squared from each side. That should help us see what's going on. At least get our x's onto the same side of the equation. Because what we then have, I'm going to bring it over here because I just have very little space with my chubby marker here. This x squared cancels out with that x squared, and this x squared cancels out with that x squared. So I get 8x plus 16 equals 16. What do we think? Is that always, sometimes, or never? If we're not sure, keep going. See if we can start to get x by itself. What would we do next? We'd subtract the 16. I would like that 8x by itself, please. Thank you. So this would give us 8x equals what? What's 16 minus 16? 0. Is there ever a time when 8x could equal 0? Yeah. Really? What would we do to get to get x by itself? Divide by 8. 0 divided by 8, is that a thing we can do? If I have 0 cookies to split among my 8 friends, does that work? I mean, I don't have any cookies to share, but yeah, I can have x equal 0. X can be 0. 0 is a fine number. We always have a tendency to like hate on zeros because we don't like them. I feel like we shouldn't have 0 cookies, but we do have 0 cookies. That's okay. So this would be a sometimes. This only works when x is 0. This only works when x is 0. So when in doubt, try and figure out what x is. If I get x is anything, 0, a third, 700, 437.2, doesn't matter. If x is something, it's sometimes. If you get x is, always will have my x's cancel out and be true. Like 4 equals 4 or 24 equals 24. Never will give us something false, like 3 equals 12. It just doesn't. Okay? So these squared ones are going to be the ones that kind of kick us in the teeth. So be careful with those and go slow. Let's look at C, and then I'll probably leave D for you guys to do on your own. What's up?
You said never would be left there?
Never, our x's would cancel out and we'd get something false. So let's look at C. Actually, we'll probably do D too. What can we do on C to figure out what's going on here? Combine like terms. I've got some like terms on this side, and I've got some like terms on this side. I've got 5x plus 2x, giving me 7x minus 3. And I've got 3x minus 8 plus 5 gives us minus 3. What are we going to do? Oh. Subtract 3x from both sides. Minus 3x. Minus 3x. That'll give us 4x minus 3. I'm going to put that to the side just because that bottom one's getting real close. 4x minus 3 equals minus 3. What are we thinking? If I keep going, will I get x equals? Does it matter what x is? If x equals something, what does it mean? Sometimes. If x equals something, it's sometimes. Because it only works when x equals 0. It only works when x equals 12. It only works when x equals 400. It only works when x is that. Let's look at D real quick. What can I do on D to simplify this? Distribute. So we got 6x plus 3 equals 6x plus 18. We might be able to start to spot this one. What can we do? Yes, subtract 6x on both sides. So we have left over here 3 equals 18. What's this one mean? Never. Because 3 will never equal 18. That is not a thing. Three-year-olds ain't gonna graduate high school. 3-year-olds ain't gonna, buy a lottery ticket. Okay, so solving through this, trying to figure out if it only works when x is a certain number, then it's sometimes. If my x's cancel out and it's the same, it's always. My x's cancel out and it's different, it's never. What else do you guys want to work through?
I have a question.
Yes, sir.
What if it was like, instead of 0 divided by, what if it's 8 divided by 0, but then that would be never?
If it's 8 divided by 0, then it would be never, because we cannot divide by 0. It's an issue. Yeah. Yes, dear. 15. Gotta get there. 15. Ah, our literal equations, because they're literally full of letters. Let's look at our literals. Oof. All right. So what we're going to do is we're going to solve for t on this first one. So what is happening between the t and the rest of the stuff? What operation is here? It's multiplication. How do we undo that? Divide. So I need to divide all the things that are multiplied against the t. So I'm going to divide by the 5 and the r. Whatever I do to one side, I have to do to the other. 5 and r. The 5s cancel out on this side. The r's cancel out on this side. And the only thing left over here is t. So what we have on the left side is what it is. It is p over 5r. And that's actually our answer on this first one. It's just p over 5r. All we care about is getting the thing by itself. So we work from our outside in, trying to figure out what is going on with the variable we're looking for. So let's look at this one. It says solve for k. I need this guy by himself. So we're going to start with the thing that's farthest away from k and get it to go away. Which piece are we going to eliminate first? What is the outsidiest piece here? W. If I need this W to leave, we're going to multiply both sides by W because it is currently being divided. That's going to make this piece and this piece cancel out. And we're going to be left with 2k plus 1 equals G times W. It does not matter if you do GW or WG. It doesn't matter. I have a tendency to put the capitals first. But you can put whatever order you want. As long as all the pieces are in the right spot, it does not matter to me. Still looking to get the K by itself. What are we going to move next? The 1. How am I going to move the 1? Subtract it. Subtract it. So I have GW minus 1 equals 2K. Still trying to get K by itself. What do I do to get K by itself? Divide. By what? By 2. So this whole side we're dividing by 2. So my K is now alone on this side. And we get GW minus 1 all over 2. I am 100% okay with that. If you're feeling real froggy and you want to split it into 2 fractions, you can, but there's generally no point to it. Where we'd have G, that was a G, not a 6. GW over 2 minus 1/2. I don't know why you'd want to do that, but you can. Like, I don't know why you want to. But if you're feeling froggy, then leap. Go for it. I don't care. They are both right. I would 100% take both answers for 100%. Absolutely no debate. No question mark, no nothing. 100%, those are both right. I'll leave the last one for you to do. It's the same kind of vibe. Work from the outside in. What else you guys want to go through? I did fix the answer key up on the Canvas page, so now it is the correct answer key. I had the wrong one. I posted my algebra one, apparently. Because algebra is also testing tomorrow. So, if you ever see something up there that seems like it's real out of place, shoot me a message. It's probably that I uploaded something wrong. Because I'm juggling too many things in my brain. And my brain is made of Swiss cheese. Number 8. Let's get there. This one? Yeah, that's a good one. That's a good one. Let's do number 8. We're matching the equations to a situation. So we're giving you a very generic story problem. And you have to figure out which of these possible options kind of sort of works the same kind of way. It's weird, but it's a thing. So what we're looking at is contextually, which ones make sense, or at least sense-ish. So we're going to put some money in the bank. So we're going to start with an amount, and you're going to withdraw the same amount every month. So withdraw is going to be which operation? Subtraction. So I can tell already it is not that middle guy. I'm going to name these just so we talk about them. So A, B, and C. So I can tell right away it is not B. B only has plus signs. Yeah. This one best matches C. Because the likelihood of me starting with negative 20, this is the stationary amount. This is the amount I put in. I can't start with negative 20 bucks and wind up with 250 if I'm removing. So this is going to be our 5,000 minus 250x. We're just trying to match up which one fits. So then we have that a store is having a sale on car stereos. First, you get a certain percentage taken off the price, and then the price is reduced by a fixed number of dollars. So you get a coupon. So they're percent off and a coupon, resulting in your total purchase price. Which one of these fits that one? A. So this would be my coupon. And we took 25% off. So I'm still paying 75% of the price. Our 0.75x minus 20 equaling, what was it, 250? Yeah. So I'm paying 250 for that stereo. So let's look at C. Even though we know which one is going to match, let's still talk through it. We're installing carpet on a fixed budget. The cost includes the cost of the carpet per square yard and the cost of the padding per square yard plus a fixed installation fee. So if we have the carpet per square yard, we know that with that per, it's going to have a variable. And the cost of the padding per square yard, again, that's going to have a variable. So if we look up here, I have a variable and a variable. 2 variables means I've got 2 pers. Is a good way to think about it. So we had our $20 per yard of the carpet, our $12 per yard of the padding. That's very expensive carpet padding, by the way. With our $300 installation equals $1,550. Carpet padding's normally like $4 a yard, but whatevs. Say it again.
Number 9.
Yeah, number 9. That's a good one too. Okay, any questions on 8 before we move on to 9? Okay. So we've got Morgan, Courtney, and Brad are collecting donations for the hospital. Combined together, they make $73. So if we have, ooh, that's not a pen. Morgan and Courtney and Brad combined together to make $73. How can I set that up as an equation? If they combined together to make $73, how can I write that? M plus K plus B equals 73. Morgan plus Courtney plus Brad all collect $73 total. The tricksy ones in here are that Morgan collected $5 more than Brad. So we need to figure out the relationship between Morgan and Brad. I know in some way they're related. Yeah. Morgan is the same thing as Brad plus 5 because she got 5 more. Morgan is bigger. Or Brad is Morgan minus 5. That would also be fine. The last one is the most complicated one. So we've got Courtney collected 7 less than 3 times as much as Brad. Yeah, Courtney collected 7 less than 3 times as much as Brad. So we're going to do our 3 times as much as Brad, first of all, and then remove 7. So we're going to take away 7. These friends are really extra in the way they write down how they collected their money. Holy cow. What we're going to do from here is we're going to take our original black equation up there, and I'm going to use substitution to kind of smash everything together. So I'm going to take the fact that Morgan is the same thing as Brad plus 5 and put it in place of the M. Then we're going to put our fact that Courtney is the same thing as this in place of here. 3B minus 7 plus Brad equals 73. So we're using a substitution just like we did in algebra way back in the day. There we go. To substitute this in. So then let's come in here and solve this. Yeah, so we're going to combine some like terms. I've got a 5 and a minus 7. So we're going to wind up with minus 2 on this. How about the B's? How many B's do we have over here? 5, because I've got 1, 2, 3, 4, and 5. What can I do to solve this? How can I figure out what B is? Add it. Yeah, add 2. So I get that 5B is 75. And we can use a calculator. What does B equal? Use a calculator. We have them. They're tools at our disposal. B is 15. That tells me how many songs or how many dollars Brad collected. So how much did Morgan collect? Morgan got 20 because it's Brad plus 5. We can use our calculators to figure out how much Courtney collected. Yeah, because it's 3 times 15. Yeah, no. Oh, yeah, 45. Sorry, my brain like stopped there for a second. 38. You're right. My brain just like stopped at 30 for some reason. I'm like, Okay. Questions on this one. And if we put our solutions like this, I'm 100% okay with that. That's my answer. I'm good with that. What else do you want? 11. Is this a valid operation? Is this a thing that we're allowed to do? Did they follow math rules? What's up? Yes, I'm gonna do this. So we're looking to see if this is a valid operation. So what did they do here? How did they get from this side to here? Yeah, they multiplied 2x plus 5 on both sides. Are we allowed to do that? Yes. So yes, this is a valid operation. They multiplied by the denominator. In fact, that is how we solve those. Denominator helps if I spell it right. You're allowed to multiply by the denominator. Totally fine. What about B? No. What should they have done? Yeah. They should have distributed. They just dropped the parentheses. I'd also be okay with that. They just dropped the parentheses. It should be 5c plus 5df equals 10. Or you could do something like it could be c plus df equals 2, and they could have divided. There's a lot of different options you can take on here. Thank you so much. I was gonna have to go find out where that was.
I got it.
Thank you, sir.
I'll get you details on it. We
Yay.
can talk later.
Sounds like a plan. All right. So they should have distributed. They just dropped the parentheses. You can word it however you want. Just let me into your brain. All right, let's look at C. What did they do? They moved the 5. They subtracted 5 from both sides, right? What else did they do? They minused 3x from both sides. Are we allowed to do both of those things? Why not? So they put them next to each other, so it's okay to move it. I can move it wherever the heck I want to. If I simplify this, I'm going to have 7y minus 5. And this 5 cancels out, and we'll have 1x over here. So what they did was fine. They just did two things at once, which is, you know, not recommended, but it's fine. It's fine. It's not great, but it's fine. Oops, there we go. They subtracted 3x and added, oh, and 5 at the same time. So it's fine. It's not ideal. I'd rather you guys do one step at a time, but they did fine. It's okay. What about D? No. Can I put together an x squared and an x? Can I smash them together? No. Can I smash them together? No. Can I combine an x squared and an x? No. So stop doing it. Okay? I cannot combine an x squared and an x. In fact, I'm going to switch this to a different color so we can make it very, very apparent. No. Cannot combine x squareds and x's into one term. Do not smash together. Stop combining x squareds and x's. They are different things. Yeah, here's one second. I have one more element for this. This is an apple tree. This is an apple pie. They're related. They're not the same. Don't shove a tree in your pie. They're related. They both involve apples. They're not the same thing. Apple tree, apple pie. Don't smash together. Y'all get really sick of that when we get into quadratics. X squareds are apple trees. X's are apple pies. They're related. They involve the same stuff. They're not the same. That one bothers me. Okay, that one bothers me. Okay, I'm sorry, Fathia. Which one did you want to do next? 13? We're trying to figure out what they did wrong, what they did right. I'm not a fan of the way this was worded. It should have said something slightly different, and I'm trying to remember how I fixed it so it was clear, because right now it's a little bit unclear. And my answer key has wandered off. There it is. I wish that it had said the 5 siblings each baked bee brownies together. So change this to have the word each. Baked bee brownies together this weekend. They each baked bee brownies. They threw away 15 burn brownies in total. And they split the rest evenly. Each person took home 5 brownies. How many brownies did they make? So Sydney made up this equation. What'd she forget to include? When in doubt, in a problem like this, if we're trying to evaluate someone's mistake, go through and write your own equation. If 5 siblings baked bee brownies, how would I write that down? 5b. They threw away 15. How would I put that in there? Minus 15. and they each took home 5. So how many ways are we splitting it up? 5. So we've got to take however many brownies they made and divide it by the number of people. So they took home 5 brownies. I'm pretty sure I have this wrong on my answer keys. I forgot to divide it by 5 people. They each took home 5 brownies, but they split it amongst 5 people. Sydney forgot to include a couple of pieces of information. She forgot to include that they split the brownies and she forgot to include that there are 5 siblings. Baking. So you got to watch out for words in there. It's being very specific about our words. And I think I even missed that on my answer sheet, that there are 5 siblings. Yeah, I missed the split. So if you go through and write your own equation, it'll make it easier to figure that part out. Okay, so when we're evaluating, you got to show me what's in your brain, okay? We got like 6 minutes left. You guys want to do one more, or you want to have a little bit of time to work and look at stuff? I'm hearing no ideas, so I'm going to give you the rest of the time. Okay? Work on stuff, ask questions. If you're working on stuff throughout the evening, let me know. If you got questions, I'm happy to help you through stuff. Answer these questions.